Hello, everyone. I'm Jean Langanet. I'm a geostatistician at Geovariances, which is a firm inside a data mine. We are here today to discuss about Isatis.py, a new product, a product we launched earlier this year, and we wanted to show it again for those who don't know it yet, and to discuss a little bit about the novelty and the future of Isatis.py. So Isatis.py is a geostatistical Python package, which we developed. Okay, this presentation will last around half an hour. If you have any questions, do not hesitate to write them down in the chat or in the question and answer tool. I will answer them after the presentation. Okay, so first of all, why do we need to use a geostatistical Python package? It is because nowadays the deposits that are exploited all around the world are more and more complex, and the modeling of the exploration, the mining, the planification, and end of life are more and more complex, and each step have now its dedicated software or code and so on. So this has a consequence. It is that if you automatize your world procedure, you have to deal with many different tools, many different softwares. And at the end, if you need to update it, if you want to do some maintenance on them or understand it again, it's more and more complex and it can be quite tedious. Thus, this is why we wanted to develop this geostatistical Python package, which can helps to simplify the workflow, your procedures. So, Isatis.py. It is a geostatistical package, and we choose Python because Python is a very common language. It is known by most of the engineers today, mining engineers. It is easy to learn it. It is very flexible, and there is a huge amount of different libraries and different tools. This is why in Python, when you have a procedure you want to implement, you can easily customize it to create the perfectly adapted solution to a problem. And here in Geovariances, we developed geostatistical algorithms and algorithms to process mining data. We have it here in a C++ library, which is a performant and optimized programming language. And we use it, this geostatistical library in C++, in our different softwares, like Isatis.neo. And with this library, Isatis.py, we grant you access to these optimized algorithm in C++ in order to implement your geostatistical procedures. The strength of a package, it is in Python, it is that it can be used in many different manners. For example, any geostatistician or data scientist can run it on their own laptop, for example, in Jupyter notebooks. Or if you have a more complex procedure or long procedure, you can save the script and make it run on computational clusters or maybe cloud services as a backend for web services. This multiplicity of use make it easy to use inside your companies. So in Isatis.py, there is many tools, either geostatistical tools or tools in order to prepare your data, in order to make robust routines. For example, we can mention some tools in order to prepare your mining data, your boreholes data, like the desurveying, the compositing, or the declustering tool. But it is a geostatistical library. So of course you will find in it every classical algorithms in order to make variography of good quality, for example, using multiple direction for your variogram, or on multivariate data sets. There is a kriging tool with many options, either point, block, ordinary kriging, simple kriging, and so on. And if you are interested in the uncertainty in your deposits, we have also continuous simulation tools, churning band simulations, sequential Gaussian simulations, SPD. And if you work on complex data set, we have more advanced tools. So for example, you can work on a deposit with a very varying anisotropy, and you can compute local anisotropies or dynamic anisotropies map inside Isatis.py. There is tools in order to manage this varying anisotropy and use this varying anisotropy in our algorithms. So here you have an example of a simulation realization. If you deal with the categorical variables, which can be either facious or domains or so, we have also categorical simulations tool, truncated Gaussian simulations, pluri-Gaussian simulations, or sequential indicator simulations. And in your dataset, if you manage a multivariate dataset with many variables, with very complex relationships between them, and you want to reproduce in your results, in your estimations, these relationship, we have a PPMT tool, which is specifically designed to answer this issue. And with the geostatistics, in the geostatistical domain, there is many dedicated objects in order to perform our estimations, such as variogram, such as Gaussian anamorphosis, support correction, and so on. And these objects can be quite difficult to visualize. So we propose different graphical tool in order to display automatically these specialized objects. And the library is quite dense. There is many tools which can be highly customizable, and every classes, every methods, every parameter is documented in a documentation, user's documentation, which is with the library. And starting to work with a new package, a new library, can be a challenge. And in order to help anyone to learn autonomously to use it, we give access to around 20 tutorials in order to learn how to perform PGS, variography, or anything. Yep. And one of the highest interest of Python is its interoperability. So we tried and we managed to combine in scripts Isatis.py with other tools, either to help you to visualize complex 3D models, or to work with other scripts like fluid flow solvers if you are working on porous media, or if you have interest in data mining or data science, you can also use machine learning packages. So now I will present you the library, an example of use of the library. Here. So I will use Isatis.py here in what is a Jupyter notebook. A Jupyter notebook is a particular script in which you can combine Python scripts, like here in this cells or this cell, and Python results, like this table. So first of all, we are working with real data. So in order to manage these data, we can use one package, one very common package, which is pandas. Here, in order to display our data and our results, we will use matplotlib, which is also a very common package. And then we can import Isatis.py in our script. So in this webinar, we are working, I'm going to perform a resource estimation, a kriging, on a real data set, the Carajás iron mine. So using pandas, we are going to import the input data, the borehole samples. And in order to look at what is imported, we print the coordinates and the iron value of the 5 first samples. If you want a more global visualization of the data, we can print statistics of the data. So we can see that we have more than 2,000 samples, and we can look at the iron mean, the maximum, and the minimum of my samples. Then I have to create the Isatis.py databases. So from my imported sample, I create the Isatis.py database on which we are going to work. Since the data are spatial, we can display it. So here is a map of the different samples. We can see that it is there is region with less samples and region which are densely sampled. And we can look at cross sections as well. So when we are performing resource estimations, it is important to have robust statistics of our sample. And the heterogeneity in the sampling might create some bias in the results. So in order to solve that, we are going to use the first Isatis.py tool, the declustering. We are going to compute a weight on each sample to balance the sampling density of the samples. So we create the declustering runner from the package, and we give it the input databases, in which are the samples. We indicate which variables are the coordinates, what is the variable of interest, and the name of the new variable. And then we perform the declustering using a moving window. We give the size of the moving window as a parameter. And it returns a new database, a copy, in which we have the new variable. So we can look at the statistics of the new variable, the weight, and we can see that on each defined sample, a weight was computing from 1 to approximately 0 in the more densely sampled area. Okay. And we can look at the results in a map, and we can see that in the dense area, we have low weights. The objective of doing this is to compute robust variogram. So now we create the variogram runner, which will compute the experimental variogram. We give it the input databases, the coordinates, the weights, and the variable of interest, and it returns, first of all, we give it the databases, and then we compute the experimental variogram using the variographic parameters that we want to use on our variography. So for example, in the normal direction, normal to the reference plane, we want a lag of 15 meters and a maximum distance of 150 meters. And it returns our experimental variogram. To display it, this geostatistical object, we can use the Isatis.py variogram display tool. And we can see in the 3 directions the experimental variograms. Once we have it, it is important to model the variogram. So we can use the second important tool of the variogram runner, which is the automatic fitting variogram model. So in order to fit this variogram model, we give it a variogram model structure guest list. Either we prefer, but either it will be spherical structures or experimental structures, exponential structures. And we fit the variogram model on the experimental variogram using the structure guest list. And it returns a variogram model. And we can display the results with both the experimental variogram and the fitted variogram model. And of course, we can have access to the exact variogram model parameters. For example, the ranges in each directions, the seal, the nuggets, and so on. Okay, so we have our variogram model, but we want to compute a resource estimation on a domain. So first of all, we have to create the domain on which we are going to estimate the iron. So we create a grid geometry from Isatis.py, defining the region, the cell size, and the number of cells in each direction. And from this grid, this new grid, we create the Isatis.py databases. We are going to write down our results on this grid. And then we are going to perform a block kriging. So kriging is a very powerful tool, and it can be parameterized using many different manners. And one of them is to perform a kriging using a neighborhood. For each estimated cell, we are restraining the samples which are going to be used to compute the value. So for example, here we defined a neighborhood built with 8 sectors, and it needs 4 samples in each sectors using this size, and so on. Neighborhood can be also finely tuned, finely parameterized. For example, here by adding a rule that say if the neighbors is further than this distance and its value is higher than this one, cap it in order to limit bias of too high neighbors. And then we can compute the kriging. So we create the kriging runner, give it the conditioning data, so the input data with the XYZ coordinates and the iron, and we give it the grid on which we are going to compute our results. And finally, we perform the kriging using the variogram model, the neighborhood we just defined, and a discretization in order to compute a block kriging. So we're going to take into account the support on which we compute our kriging. And then it returns the grid with the new values. We can look at the statistics. So we estimated 130,000 cells, and we have the statistics of the kriging estimate and its standard deviation. And we can look at cross sections. So it is another tool in Isatis.py. It is possible to automatically display cross-section of a grid. So here is a map, slice, horizontal slice of the krigged iron. And here is the standard deviation. We can see low value of standard deviation close to the conditioning data point, of course. But it is a 3D data set. So we might want to look at it in 3D in order to visually control the result. So to do it, there is multiple package that can do it, and we can use PyVista, which is dedicated to look at to display 3D objects. So we create the object to be displayed, which is the krigged iron. We also add the sampling, the conditioning data, and we plot it. And so here it is. We can see we can see the conditioning data points here, every boreholes, and our grid. I added a clip plane in order to look at the different slice, of the grid in order to control what are the results inside the grid, and I can easily orientate the slices. So as you can see, it is quite easy to combine the results with other tools. Okay. Okay. So Isatis.py is available today as a standalone Python package. As you can see, I just used it directly without any other software needed. It is available both on Windows 10 and Linux. For example, if you have some computational cluster in Linux, it can work on it. And in the library, there is of course the documentation. And we continuously improve it in order to add to it some new features, some new tool, and to add the latest innovation that we have in Geovariances. For example, this year we added different completely new tool. One which is contact analysis, another one which is an unfolding tool. So when you have a layer very folded, you can unfold it in order to perform a more robust geostatistical estimation, a resource estimation in it. There is a conditional expectation tool, and we also improved the tool already existing in it, like the PCA or the declustering tool. In the next month, we are going to continue to add a new feature in the Python library, continue to improve the existing one, and we currently are working on creating a bound between Isatis.py and Isatis.neo in order to make Isatis.py able to directly work on Isatis.neo databases or performing an Isatis.py resource estimation, and at the end of the procedure, directly creating a new Isatis.neo project in which will be stored the results and the different objects, neighborhood, diagram, and so on. Okay. So to conclude, in Geovariances, we have a strong experience in geostatistics and implementing it in a powerful and optimized way. We did it in our C++ library, and now it is accessible from a Python package. The advantages to use this shared geostatistical C++ library is that the algorithms are tested for a long time, they are optimized for a long time, and thus you can compute with Isatis.py very performant routines, and you can trust your results because the algorithms are tested for years in Isatis.neo, in Cartotrack, and so on. But it is in Python, so it is very easy to test, prototype your estimation procedure ideas. And since it is the same algorithms, for the same parameters set in Isatis.py, you will have the same results as in Isatis.neo. So you can completely trust what you are prototyping. And we continue to regularly, and we will continue to regularly release new version of Isatis.py in order to maintain it and give you access to the most recent features that we have here in Geovariances. So as soon as you want to perform a resource estimation procedure, or if you want to compute complex geostatistic and you want to do it in an automated way and efficiently, you can use Isatis.py. Either you want to do just a geostatistical analysis of your data, or go into variogram modeling, Kriging interpolation, simulations or risk analysis, or if you want to perform uncertainty quantification on your deposits, or if you want to do geological modeling, you can do all of this in Isatis.py. In Geovariances, we not only build new softwares, or we not only do software, we also propose services in order to make you gain more experience in the software you use, or helps you to work with them. So we have a customer service to answer your question on either software we have. We also have some trainings that are available on either the softwares, Isatis.py, for example, or the geostatistics. For example, in 2 weeks, starts a training on the use of Python and Isatis.py. And we also have a consulting service in order to implement robust and auditable procedure that you might need. So, as I told at the beginning, Geovariances is part of DataMine, and this is a very important strength since we are present. We have product and solutions at every step of your mining modeling, either exploration, geology, mine planning, production, at the laboratories, or at the sustainability. So we are present all around the world. So if you have questions, there will be always someone that can answer you perfectly.